Okay, so this is the sheet that I had up on the wall, and we did the left side in class. So now I'm going to do a similar, no pun intended, question for each one we did today right next to it. So as you scroll down, I made a new problem for each one, and that should help you considerably tomorrow on the test. So the first one, make sure you pause the video and copy that picture down, because if you don't hit pause, you'll never be able to keep up. So once you have this drawn, you notice that there is a corresponding set of bottoms and a corresponding set of, I guess, right sides. So that 18 you don't need. So what we have is 8 over x equals 5 over 21. You could also say 8 over 5 equals x over 21. Either way, you're going to have the same cross product. When you cross multiply, you end up with 5x equals 21 times 8, which is 168. When you divide both sides by the 5, you end up with x equals 33.6. So here is a side splitter problem. And you can do side splitter when you have parallel lines. You have to make sure they're marked parallel, and just the sides are labeled. So we have 13 over 18 equals 17 over x. We cross multiply, we have 13x equals 18 times 17, which is 306. Divide both sides by the coefficient of 13, and we end up with x equals a really crazy decimal, so we'll round off to the nearest tenth, 23.5. And it did go on past that, so don't think you're wrong when you got that on your calculator. Next one's just an angle bisector theorem question. It's the same thing, as same idea as the side splitter, in that if those two angles are the same, they open up to proportional sides. So just the way it looks, 4 over 3 equals x over 6, and solve it from there. So you have 3x equals 24. X would be 8. Okay, make sure you draw this one again. Pause to make sure you have time to get it correctly down on your paper and fairly neat. And then once you're ready, start it back up again. There's an extra number like there was today. It's in a different spot. You have corresponding sides here and here. So that's the one that has no partner on the other side. So we don't need that 4. So it's still just the sides and not the bottom. So we can use the side splitter theorem of 12 over 7 equals x over 9. You could do 12 over 19 equals x over x plus 9. There's nothing wrong with that. You just don't have to go that far if you don't want to. So down here we have 7x equals 108. Divide both sides by 7. And again, you have kind of a funky decimal, 15.4 for x. Now this looks similar to a side splitter problem, but it's not, because we don't have two sets of sides. We have the bottoms. There's a missing x on here. It got deleted right there. So since it's not a side splitter, we have to redraw the triangles. Anytime the bottoms are labeled, we redraw. So the little triangle has a 4 there and a 14 there, and the bigger triangle has an x plus 4, not 4x. You add them together. So it's x plus 4. And on the bottom we have 26. So taking that, we have 4 over 14 equals x plus 4 over 26. And then we'll cross multiply, find the cross product, and solve for x. So we have 14 times x plus 4 equals whatever 4 times 26 would be. Don't forget you have to distribute there. So we have 14x plus whatever 14 times 4 is, and that's 56, equals 4 times 26, which is 104. We're going to subtract 56 from both sides. And we have 14x equals 48. Divide both sides by 14, and you have 3.4. If I round to the nearest tenth, it does go on beyond that, but we'll say nearest tenth. So I'm going to leave the first version that we did in class today visible on the left there, so maybe you can compare how we did this. The volumes of two similar figures. So again, we have volumes of 64 and 216. So that means that in the volume slot, we have 64 and 216. Before we go any further, now that we know that, let's figure out the rest of the chart. The cube root of 64, be careful, not the square root. The square root is 8, but the cube root of 64 is 4. What times what times what? 3 times gives you 64, and that is 4. What times what times what gives you 216? That's 6. You can always just go to your calculator and type in math 5 on your calculator. I'm sorry, math 4. If you hit the math 4 keys, and you can find cube roots that way. But 64 and 216 go back to 4 and 6. Once we square those, it's 16 and 36. So now we have the side ratio, the area ratio, and the volume ratio. But the one they're asking for here, just like the one in class, was area. So now we're switching over to the area of the smaller one is 22. So the area is all I care about. I don't care about that or that. I only care about the area. The area is 16 over 36. And the smaller is 22 on the other side. Smaller one's on top. So 22 over x. Then we cross multiply and solve, and you're done. 16x equals, I believe, 792. Divide both sides by 16, and you will get x equals 49.5. You can compare it to the problem we did yesterday. Not yesterday, this morning. And then we have the similar right triangles problems. So this is different than the one in class. This one we had to factor. I don't know if that's going to happen on this one, so let's see. The two triangles that have two things labeled are that one, the small. The small one has a short leg of 4 and a hypotenuse of x. We don't know the long leg. The medium triangle only has one thing, so I'm not using that, but I am going to use the upside down giant one here that has a short leg of x and a hypotenuse of 9 plus 4, which is 13. So I have what looks to be a ratio right there, 4 over x equals x over 13. Cross multiply, and I have x times x is x squared. 13 times 4 is 52. 52 is not a perfect square, so it's not going to break down super easily. But 52 has two factors, one of which is a perfect square. When you break this down right here, I see people not putting the square roots here. They're just putting numbers. The numbers are 4 and 13, 4 times 13, but I see people doing that. That's technically not true, and it forces you into some mistakes sometimes. It's radical 4 times radical 13, because then you know that the square root of 4 is 2, and that one stays the same. Otherwise, people are unsure when you have the radical and when you get rid of it. So the final answer is 2 radical 13. And this is the same one from the that I had on the wall today, but we kind of had to rush at the end of class, so I'm going to do the same problem again. How do you get this one, which is, try it again, that one, onto DEF? So I had to pay attention to how it was worded there. So there's a couple of steps, and you can do them in different orders, or there's probably multiple ways you could do it. But the way I saw it was translate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the first thing I did was I translated over 10 up 11. My other step's going to go before it. Then I dilated by point E. I'm going to stay in corner E. So dilate E comma half. So I would dilate by point E by a half. There's another way, and there's multiple ways to do it. You could have dilated first, then translated. You could have translated so that F mapped up onto itself, and then you would just change the E to an F as your center of dilation. Same thing with D. So there's other ways you could do it. But the important part is you're specific. Don't just tell me that you translated and then dilated it. Tell me how far and what direction did you translate it, what's your center of dilation, and what was your scale factor. I would do these problems if you're comfortable and this all made sense to you tonight, then you're ready to go. Or watch the video again an hour or two from now and do them all over again, because that's how you study for math. This will be a big test grade in the second quarter.